feature-rich GPU-assisted scatterplots for millions of call events. Here we have our application with a month's worth of data loaded. On the left-hand side, the number of loaded calls can be seen, along with the number of rendered calls and the number of customers this represents. We also have an indicator of the rendered calls as a percentage of the loaded calls. The number of rendered calls is less than the number of loaded calls due to erroneous data being removed in a pre-processing step. The main window shows the plotted data. Here we have the default view of customer effort score against the date and time of each call. Immediately obvious is the periodicity of the call, with troughs during the night and peaks during the day. Call points are coloured according to the origin, be it agent-initiated in green, customer-initiated in red, or customer-initiated without agent interaction coloured blue. Users are able to choose alternative colour maps and also change the attribute that the colour is mapped to, with a choice of call origin or net promoter score. Users are able to change access variables with the use of drop-down menus. Various call attributes are available. For example, here we have call duration. The same variables are also available on the x-axis, along with additional variables for the time of call, the end time of call, and the normalized time for the call. The normalized time specifies the amount of time a call is after the first contact of a customer. A scatterplot matrix is available to provide an overview of all available variable combinations. Available variables are time, normalized time, end time, customer effort score, cost, call duration, agent duration, wait duration, IVR duration, hold duration, and time of day. Users are able to click a plot of interest to bring the view up in the main window. Users are able to zoom in on the data by adjusting the sliders with each axis zooming independently. Alternatively, scrolling the mouse wheel zooms towards the mouse pointer on the x-axis. While zooming on the y-axis can be achieved with the use of the control modifier. Users can click to drag and pan the scene. Here some interesting patterns can be seen in the data after zooming. Domain expert feedback into these patterns suggests that these were caused by variations in staffing levels within the call centres. Due to the uneven distribution of the variables, with most data clustered towards the bottom of the y-axis, a logarithmic scale can be applied to some variables on the y-axis. This reveals some spaces in the data that require further exploration. By changing the y-axis variable to cost, we can see a distinct separation in the call origin. Calls who do not speak to an agent, in blue, have the lowest cost, followed by calls originated from the customer, in red. Agent-initiated calls, in green, are the most costly. Here we have the time of day against the date and time of a call, with point size mapped to call duration. Points are coloured by the feedback net promoter score. Our application features two categories of filters, customer filters and call filters. Call filters process individual calls using call variables such as agent duration and wait duration. Customer filters meanwhile enable filtering of groups of calls that belong to one customer. Examples of customer filters are the number of calls and the total call duration of all calls. Here we demonstrate a fast filtering speed with over 4.5 million calls quickly processed. Calls that do not feature a feedback score, in green, are easily and quickly removed. Calls that are excluded by the filter are rendered in an opaque grey in the background to provide context. Notable here is that the majority of the longer calls are at times before 1400 hours. Our filters feature a histogram to provide an overview of the distribution of each variable of the calls. Clicking the button for a particular filter brings up a dialog for that filter. Larger distribution histograms can be seen along with controls for varying the filter limits. Moving the sliders controls the limits of the filter. This also updates the lower histogram, allowing for the distribution to be seen once the filter has been applied. Specific limits can also be entered manually. Once the user is happy, the filter can be quickly applied. The button for that filter turns red to show the filter is active. Multiple filters can be applied at the same time in a logical AND operation. The user is able to use the mouse and right button combination to lasso calls of interest. This brings up a dialog with the full details of the brushed calls. This feature satisfies the last section of Schneiderman's visualization mantra of details on demand and was specifically requested by an industrial partner to enable further analysis. The software is also capable of calculating and displaying some call metrics. Here we show call arrival rate. The weekends are easily distinguishable with less calls. We are also able to show the metrics for an average day for comparison, shown here as the second dashed line. Because of the difference in call load over the weekend average call load is calculated separately from the weekday value. Noticeable is that Mondays are the busiest, with Thursdays the quietest. A noticeable spike in call volume can be observed on the 18th of February. This sudden increase in call volume was not evident in the scatterplots alone, but with the addition of call metrics becomes apparent. We show this abnormality to our domain expert feedback to try and establish a cause. However, without further investigation, an explanation was not evident. Possible causation hypothesized were a technical issue or errors in the dataset. Other call metrics are available, such as call wait time. An animation feature allows for the exploration of data as if the calls were arriving. Here we have agent duration against time of day for multiple overlapped days. Users are able to change the amount of time the animation should last. A progress slider shows progress through the animation. Users are able to interact with this to manually select a time. Users also have the choice of how to render calls after hang-up. They can be displayed continuously, removed, or rendered in context. By using this feature, a peculiar aspect was highlighted in the data that was difficult to see without the animation. On one particular day, a row of calls appears. The cause of this is unknown. This application was developed in partnership with an industrial partner who provided domain expert feedback. Following is a quote from our feedback session.
Because you can look at a large set of data and get an overview and filter down to a smaller number of calls, and then this application looks useful for that, and then potentially you go and look at some more specific detail with another application, or even you just literally go to the database and you take those call IDs that you've listed out there, and you even just go direct to the database.